You know that. I know which one is actually. She would have.
I don't know.
She's tough. And she came to us one time because he was traveling somewhere. She had to cover him. And she said, "You gotta love the guys." Okay, thank you.
She was so bad.
I know. I know which one I do. Only three of them. Yeah.
Bless you. All right. Hello. I don't know about you, I just need to sit a moment.
Correct. You have to supervise those two that right with the kids.
Yeah, and then earlier we were discussing renovating this building, and yeah, I think mostly good things, but you know, there's a few things we had to like correct with the architects and like high leverage stuff, so a little bit.
How long has that been discussed? I feel like it's something. Long time.
Well, 2 years, I'd say more seriously for about half a year, but yeah, and we were talking about like, do we want slow, less intense, but slow renovation versus just rip off the Band-Aid, get it done, but it's faster. And I think most people are like, let's get it done. Yeah, they want to start latest August of next year, but hopefully as soon as like May or June or something. Yeah, well, we have 4 chem labs, but we'll only have 2 for like a year and a half. Just to get renovated. And
What exactly are they renovating?
our labs are like, so a lot of the building. Number one, our labs are just beat up and old. They aren't compliant with the American with Disabilities Act. Our plumbing is crap. Our electrical is crap. We're kind of at the point we plug in one more instrument, the whole building will lose power. Yeah, we have always random departments here. We want to claim it permanently. Nothing gets arts. I love art, but anyway, so there was a kindergarten here 2 years ago. Not kindergarten, preschool something, whatever that. Yeah, all my kids are grown past that age, so I forget what it's called. But preschool, I think. Daycare, yeah, daycare, preschool. Okay. Yeah, and then ag, like they have like 2 people per office. It feels like they're busting at the seams. But yeah, so we're just trying to get everything good for everybody, you all and us. Yeah, it's like $2.5 million grant, and we gotta spend it soon, or they take your money back. That's how that stuff works. Okay. Y'all were my therapy. I appreciate it. All right. All right. So today we're going to talk about the final. We spent a little bit of time talking about the formatting of the final. So we'll do some discussion that today, but the most part of today will be just kind of reviewing the list of topics that I want you to brush up on before the final. Okay. Some people have done it already, and just a few. Their word on the street is there is some math, but you got to kind of just know your stuff, know your concepts, and let's see, what else did they say? Yeah, some math, but just kind of a lot of concepts. So when I was perusing it, it was just like a little bit of everything. And I feel like for a lot of questions, if you kind of know what they're getting at, you can get to an answer without overly taxing yourself. A lot of people get scared of like, oh, there's going to be like 3-4 step dimensional analysis conversion stuff. No. Like I saw a like stoichiometry, limiting reactant sort of thing, but you know, it didn't take forever because like stuff was already in moles or something, you know, stuff like that. And so it's kind of like just fitting it out. And yeah, both the students I did it with this morning, they both left early. I'm not saying that's going to happen to everybody. I know me, even if I finish early, I'm double checking until like they rip the pencil from my hand, you know, and or I just start to feel too much anxiety. So you know yourself. All right, so it's all multiple choice. You have 55 minutes, 60 questions, and all multiple choice. There's only 4 choices for each question. It's not like 5. Okay, just 4. Okay. Your exam packet will have you know, you'll see the first page, and the first page it's going to look really random. It's going to have the list of authors on it and a bunch of legal disclaimer crap. You know, don't bother to read it or you'll like have an anxiety attack. You know, just open the next page and then you'll see that there's a periodic table at the bottom. Okay, and then at the top will be just a few constants, not many. Okay, so there's no, let's see, they don't have speed of light or Planck's constant. They don't have temperature conversions for Fahrenheit, Celsius, Kelvin. Ooh, I'm 1 letter away from a bad word there, I just noticed. Anyways, but you got to know those yourself. Okay, let's see, what other constants?
What was the second one you said? Like,
like, you know, for like E equals H and U a long time ago, C equals lambda and U, and everyone gave me crap, and I deserved it. That I forgot to put the speed of light, the light constants on there. On the exam too, I forgot to provide those. Well, they're not providing them either, so boo to them. Let's see. Basically a long list of things they don't provide. They don't provide Avogadro's number. You gotta know that. Yeah, they don't give any equations. They don't give you nothing, but they do give you the periodic table, but it has no names. But honestly, the elements they ask you about, like you already know them. All right. At this point in the semester, everyone knows that N is nitrogen, as K is potassium. I mean, they're not going to be like what is you know RH. Yeah, they ain't doing none. So it's all like basic everyday elements. There was no surprises. There was one element on there, but they had already that we hadn't talked over this semester, but they provided a name for it, so it wasn't even a factor like in that. So like the no names won't be an issue. They do give a gas constant. That we used for lab calculations. Okay. So if there's any gas things on there, That would be for use in PV equals nRT. Okay. I think that's the only constant they give is R. Yeah, they don't give anything else. Lastly, we kind of have this semi-memorized by now, but like, you know, milli, they'll tell you that's like a 10 to the -3, or no, +3. And then kilo, they'll tell you it's like 10 to, they'll give you those two, but they don't give you nano, they don't give you micro, they don't give you the only, yeah. Oh, centi, yeah. Yeah, but yeah, so they don't give you centi, they don't give you micro, they don't give you nano. Okay. So yeah, you get this, you get a periodic table, you get that, that's about it. Okay. But you know, like a lot of questions, like you're not going to need, you'll have to do some temperature conversions, no question. I can look to see if there's photon stuff. I can get back to you on that. And then Avogadro's number, like 6.022 times 10 to the 23, we've used that a bunch now. So like that shouldn't be an issue. Okay. So, okay, let's see. We talked about 51 minutes, 60 questions. Okay. The packet, you're going to go through page 6. And then it doesn't have a stop sign, but I'm going to tell you to stop at page 6. Okay. When you get the packet, it's going to say GOB on it. Okay. G stands for general chemistry, general or intro. And that's us. Okay. And there's only 60 questions for that portion. That's all we're doing. The first 6 pages, those first 60 questions. The OB part we're not going to do. That's another 6 pages, and then the B is another 6 pages. So it's like an 18, 20 page packet or something. The OB, this is for Chem 102. And this is not Chem 102, this is Chem 101, the general intro part. Okay.
So you have 180 questions?
There's 180 questions in the packet. Most institutions break apart general and organic biochemistry in either 2 to 3 semesters. There's some insane places that they make it like a 5-credit class and they cram it all into 1 semester. All right. Yeah, I wouldn't do that either. Okay. It's too much, way too much. Okay. So yeah, CSI, most people just need the 101. Only a handful of like health science sort of majors maybe need the 102. So yeah, just that first part of the packet. All right. There's no penalty for guessing. So like if you don't know, like please guess. You have a 25% chance of getting it right. And so please guess. Okay. And again, my recommendation is go through the packet, do what you know, and then the remaining time is you have a tally of like I couldn't figure out number 1, 17. I didn't know how to do 43. And then you have those, and then you go back to it with your remaining time. Okay. You're not allowed to write in the packets because we do reuse those packets sometimes. And so, so try not to write in them. If you accidentally like make a stray mark, just erase it. If you can't get it out, just let me know and I'll take care of it. Okay, let's see. Other random things that are random but kind of important. Oh, like bathroom. We're going to try to get here like 10, 15 minutes early. Even earlier if you want to. Get your bathroom and snacks, all that done beforehand. You can leave the room, except you're not allowed to come back in. So leaving a room is interpreted as a submission of the exam, hopefully for obvious reasons, because it's a high security sort of thing. I'll clear calculators at the beginning. The exception is if your calculator is one of the cheapo ones that has no memory, then I'll just kind of wave you off. Although if you have the cover on, I will look to make sure you got nothing stashed in there. Oh, when I was at Iowa, I had someone with the answers written into all caps. So I'll just like Okay, I didn't actually
That's it.
whack it off. That's probably a lawsuit. But I just, hey, take that off. Let's see. Yeah, I know in high school, people would have the covers and then they jam their sheets into there. So, I haven't caught anything crazy like that here at CSI. Y'all are honest people, knock on wood, you know. Any questions so far? I know I'm rambling a lot.
This is on Monday, correct?
No, Wednesday.
Oh, it is?
Yeah. So y'all are Wednesday, 11 a.m. Okay, and like be here 10:45. This same room of Evergreen C76. Okay, I am recording this and having my online students watch it. So for online students watching this recording, oh, I crossed out. No, this is you all. For my online peoples, it's whatever you signed up for in that email I sent yesterday. Okay, but everyone in this room and on the internet, Rachel, get better soon. Okay, be here 10:45. Yeah. Okay. All right. And then those who emailed me for different arrangements, you know who you are. Obviously, this time and location does not apply. All right. So that's kind of the mechanisms of the exam. Let's now talk about the grading. All right, it'll take me a few minutes to boot up the computer. What I'm going to do is I'm going to bring up the grading distribution of this exam in the past. Let me see. I think I have to log into Zoom on a computer so that anyone online can see this. I hope I'm making sense. My brain is so fried. I don't even know what English is coming out of my mouth. Start. Screen. Come on. Okay, good. All right, so, and I'll post this on the site, but ACS exams, Milwaukee. Norms. Oh yeah, Corey.
Do we still come on Friday after the test or no?
Oh, no.
Okay.
Yeah, I think they start like having graduation ceremonies. Oh, it's winter. No, they still have a winter graduate. This is their first year ever of doing like a winter grad. So that's kind of, yeah, no, Friday, yeah, this building's empty except for faculty. We're just grading like crazy. So, yeah, good question. Yeah, don't come. Unless you got brownies, then I'll eat them. Let me see. Just kidding. All right. Good organic book. And sometimes people come with cookies like, please grade nicely. Am I pliable to bribes? No comment. All right. So here we go. People are like, all right. So let's see. Did I click the right one? Good gravy. There's so many. Okay. General organic bio. There's so many stinking exams, man. All right, 2014. That's the one. I clicked 2018. All right, so I think we're doing the 2014 version. And the reason why there's like gaps between when the exam was made versus when these statistics are published is while there's many institutions that use these ACS exams, anywhere from high school to community college, all the way to like Stanford, Ivy League sort of places. Many people use these same exams, but most institutions aren't willing to share the data to the exams institute with how their students did. As a result, it often takes years before they have a big enough data set where the mathematicians can extrapolate to national level trends. So in plain English, that means a exam that we can use comes out roughly every 10 to 15 years. So 2014, here in 2024, the 2014 only became available as of 2 years ago, or 1.5 years ago. We were using a 2007 2 years ago. It was like almost embarrassing. All right. So here's the norms. All right. There's 60 questions. Okay. And what you see here is not your percent correct, but it's a percentile. Percentile is your ranking put on a percent scale. In other words, a 0 to 100 scale. Okay. And so you are ranked based off of that score. All right. That sounds scarier than what it is. All right. Let me explain about the grading. So a lot of you made the comment to me on Canvas, you see there's 3 final exam grading categories. Okay. Number 1 is your raw score. Okay. So let's take a 32 out of 60, which I know it sounds terrible. Okay. A 32 out of 60, you put that into your calculator. And that is a 53%. Normally that's not a passing grade, but this is where you have to understand the intention of these exams, perhaps the evilness of it, or maybe you think it's not evil. Maybe you think it's nice of them. I don't know. I'll let you decide your perspective on that. But these exams, especially given a 55-minute time frame, they are engineered not for people to get to a high percentage. Rather, they're engineered to provide ranking, okay? So the designers have it in mind that some people won't finish. Some people will just get a bunch of stuff wrong, okay? And then they put a percentile, okay? So someone who got a 32, they're in the 50th percentile, okay? So if we look at this calculation, and I'll put it into Excel. So you got 32 out of 60. Okay, you do the math. All right, and then let me put that as a percent. And that would be, this is your raw score, okay? Now, you also get a percentile score, which is your ranking, and then there's the statistics score. And this is the curve. This is the best one, okay? I think I was saying this a little bit last time, but 50% from a grade point of view means you're middle of the pack, you're the middle score, average score, whatever you want to call it. And so that is our line for 75%. And so what you'll see once I put stuff into Canvas, you'll see the best one out of all of those will stay there. And the other 2 columns, they get like grayed out or peached out, or like they get non-factored. And then you'll see that's the one that goes to count. All right. I'm not wishing anyone a 32 out of 60, by the way. That's not what I'm getting at. You know, I hope that we all do better than that, and plenty of you will. Okay. But like 32 out of 60, that's, you know, some of your students are very blunt with me, and you're like, Josh, like, I'm just looking to get a C in this class. Just don't take it personally. Well, there you go. There's your C. Okay. All right. Now you're like, well, I want to do a little better than a C. I want to get a B or A. What does it take to get a B or an A? All right. So let's maybe take this 41. So 41 out of 60, I apply the same formulation, and that's a 68%. But from the percentile, what did it say? 81. And so we go off of the bell curve, and then based off of setting the grading system, so that 50s to 75% average, this would come out to about an 85% B. Okay. I have the exact numbers in a spreadsheet somewhere I can pass for those who are interested in that data. Okay. And then 85%, once again, would be your highest score. All right. How about 43? 43. I'm not going to do like every what if scenario, but 43 is an 86th percentile. I know for sure 85th percentile is actually our A cutoff line. So here in the 86, so this would be like a 91 or 92%, you know, we'll go with 91. All right. And then so that's the highest of the three numbers. So that's your score on the final. Okay. So yeah, that's not a bad deal. You got a roll of 72. But you're in an 86th percentile. You're in the top 14, 15% of the country. And yeah, we're going to give you an A for that. But Josh, I'm going to do better than that. I'm going to get a 46. Okay. Good. I love it. All right. So 46, 91 percentile. I think you'd get about a 95%. All right. All right. We also at CSI, we have a department incentive that we all do as chemists for 101. Anyone who scores in the top 10 percentile, so 90% or better. Oh, here's percentile. If you get 90% or better, we add 5% bonus to your overall course grade. Okay. This may or may not feel like you, but this is, you know, I've had past students, they'll admit to me, hey, I kind of coasted all the semester. You know, I didn't do all my homework. I didn't try all the exams, but I think I get it all now. And they're averaging, you know, like a mid to high B, you know, high B, and they just need to get over that hump, okay, to get to the A. I've had a few students, they crush the ACS final, and then they pull out that A with that 5% incentive. Being the 90th percentile or higher. Okay. So that's how the grading works. Basically, the grading is designed to really be generous and benefit you. Yes.
Sorry, that touches. So beside those information you said,
Yeah.
so for any reason, so you got everything is good
Yeah.
before the final. For some reason, you get sick, you're not emotionally, you know, okay,
Yeah.
your score is terrible,
Yes.
which is that 10%. Is that necessary to pass it, that 10% to get a good score or no?
The 10%, great question. We, if I understand where you're getting at, let's say everything was good until the final, and then the final, you know, you're having a bad day or something, just you saw the Times New Roman font and then it terrified you, and then, right, you know, stupid Times New Roman, screw Times New Roman. I'm guilty of it sometimes. Anyways, and then you fail. It's 10% of your grade. Okay, we don't have a policy. So it is 10%, but at the same time, it's only 10%, you know.
Wait,
I
the
don't,
final is 10%?
yeah, the final's 10%.
Oh.
Yeah,
I know,
okay.
but in some conditions, some
Yeah.
classes,
Yeah.
you have to pass that one to add it on to the other.
no, we don't have a policy of you fail final, you fail class. We understand that it's just one day in time, and that's why we have 4 other exams. That's why I dropped one of them as well, and then that's why we have the final. Yeah. Oh, but on the positive side, you aced the final. I count that as your. Oh wait, no, that was a past semester. No, I don't count. No. No, there's a past semester. It was like a COVID or something. I had to count an exam twice. No, that was 3 years ago. Never mind. Okay. Yeah, so it's just 10%. Yeah, just 10%. Yeah. If I'm being real here, I've had plenty of A students, B students, they bomb the final for whatever reason. You're like, Josh, your writing makes way more sense than theirs, whatever. Now, I hate to say it, but I'm just putting out there, like non-native speakers also, sometimes they just struggle with the formatting. We can't like not count it, but it's 10%. Yeah,
Thank you.
10%, yeah. All right. Yeah, great question, great question. Yeah, no, and I don't, yeah, and all your semester exams are 10%. I don't count the final any higher or lower. All right. Other things out there, people talk about like the essay project thing, easiest 5% of your grade. I will put a little reflection piece onto Canvas. I just want you spending no more than like, 30 minutes on it or something, and I'll have that due after the final. So that you can just like take a day or two to just kind of relax and, catch your breath and, binge Netflix all day and then, write a little reflection piece. And that's like 5% of your grade. It's like really, really, really generous. Main thing is just do it. Like I don't want to say like if I see like 5 words on it, you won't get full credit. But basically, if you give it like a half effort at least, like you'll get the credit. So.
And when would that be
Yeah.
due? After the
I'll make it due like we have Monday next week, whatever that is, the Monday after.
Okay.
Yeah, I'll have it due then or something. Yeah, it'll be some reflection piece, that stuff really helps me. So yeah. All right. So that'll be a little great help as well. Yeah, some students that ask me like for review purposes, if I can open up like old homeworks, I'm okay with that too, for review purposes. I don't know how much it's going to help your grade, but yeah, I guess you might get a little grade boost from that, from me opening up like old homeworks and quizzes and stuff. So, yeah. So yeah, if you want to take advantage of that, send me an email and I'd be happy to do that for you. Okay. All right. So I talked about the format, I talked about the grading, and the last thing, the bulk of today is going to be dedicated to the actual topics, of course. So yeah, the way to calm nervousness is to know your stuff, of course. Or that's at least half the battle. Okay. Pausing for questions here. Karen.
That practice test you have on there, are the questions similar to that on the
Oh,
test?
active one?
Yeah, thank you. Yes. All right. So the question is, so I have on the practice tab of active, I have a 60 question thing. They are, I think, similar-ish. The truth is because none of us faculties do like a study for the test sort of philosophy. I grade the topics, but I just make sure that topic is covered. I don't really get into the details of how they asked a question. And so like, I can't really predict at what angle they're going to go about a certain topic. So my goal in writing that practice is not to get you used to like those exact questions. It's just for you to jog your memory on those topics. So like if I have like an empirical formula question on there and you got it right, but you have a seed of doubt in your mind, if they asked it a different way, I'm not sure if I would get it. That moment I'm more interested in for your learning to go back to the topic and then revisit it. I mean, there are gonna be some questions you're like, yeah, I can do that, upside down and whatever. And then gonna be other topics, it's like, not sure. So this is more for like exposure therapy than anything else. I mean, you'll learn and review some things from it for sure. But I just feel like the best way to study is like if you know the topics inside and out, then you'll be ready for whatever they throw at you. Because like if you unlock the concept and what they're asking for, you get the answer like pretty quickly. You'll really like, oh, that's a gram to mole question. And if you know how to do grams to moles, then it doesn't matter whatever chemical formula they throw at you. You just do it. All right. Oh, that's a mole to mole question. So like knowing the skills. That being said, no, like I think I did get a pretty good representative sample. So I think I did a decent job there. Your first time through, I would go untimed just to make sure you're learning the topics and take your time. And a second time through, I would put a 55-minute timer on it just to kind of remove the nervousness and edge of working on a time limit that we haven't been used to previously in a semester. And I think that would be a valuable experience. Okay. Yeah, and once you've done that, then you write a list of any gaps you have. And then you attack those. And I would also go to our previous exams. You know, the online ones. I know for the like exam 2, exam 3 earlier, I forgot to toggle like see your answers, but that's toggled for all the exams now. In fact, those of you who oh, it's Friday, right? So vast majority of you have done exam 4. You go to, when you went to the testing center, I just told you to write it wrong immediately, right? So I have that there now, and you can review those as well. So yeah, the practice is the final, because I don't write it, it's hard for me to give like an exact prescription. I wish I could, but I can't. Okay. So I don't know if I answered your question or not.
Yeah.
Okay. All right. So with that being said and done, let's go through the topics. Okay. All right. So the theme of today, as I'm writing everything out, and the theme of your study, okay? Work first on cleaning up the things that you were good at, you knew how to do, but you've just forgotten. Okay? Use your remaining time to brush up on the things you're not so good at. Okay? Nothing is worse than taking a test and you got the question wrong and you knew you should have had it. Okay. We don't want any of those to happen. You get those down, that's going to boost your grade and give you some easy, quick wins. Okay. And that psychological confidence is a huge battle as you're doing an exam. All right. So that's my philosophy.
Are we gonna be able to see what questions we got right and wrong after the final?
They don't allow that, unfortunately. What I will allow is if we kind of talk in person afterwards and you can kind of tell me what you did, and then I can kind of tell you, I can kind of make a guess of whether you got it right or not. But I can't do that in a public like sort of form because these are like photocopy illegal sort of things. So, all right. So the philosophy is I want your goods to go to great. Okay. No, oh shoot, I should have known that moments. So that's number 1. And then number 2 is fix bad stuff. Fixing bad stuff definitely comes second. Okay. And let's face the truth, there's stuff that comes easily for you. There's stuff that comes more difficult for you. And you're wasting all your time trying to fix the bad stuff that's not clicking. You're wasting a lot of time. Okay. So it's that two level approach. All right. So here we go. We're going to go from unit 1 all the way down. Okay. So we started out the semester talking about mass, okay, volume, density. Okay. So mass, we'll have mass units. And the base unit for mass is a gram. The base unit for volume is a liter. We often work in milliliters. Okay. Be ready to convert between anything. I mean, masses, we see milligrams and kilograms also. So you should be able to convert between those. And then densities, they might throw grams per mil. They may throw grams per liter if it's a gas. Yeah.
Can you change the screen?
Oh, my bad.
Yeah, I was gonna say the same
Thank you.
thing.
Okay. So I ask you mass, volume, density, you know, and being able to convert in between them. If they give you a mass, but they're asking for a volume, use the density. If they give you a volume and they're asking for a mass, use the density. Okay. All right. So there's those basic units, and then there's temperatures, right? You know, we're talking is really fundamentals here. All right. So I'm guessing most people in this room forgot how to do a Fahrenheit Celsius temperature conversion. Okay, so let's write those out right now. 1.8 is also known as 9/5. Okay. The Kelvin one, I feel like most of us have that memorized by now, but there it is. Okay. All right. One of the biggest things in the first two chapters was sig figs. Okay. And let's be honest, after the first exam, we were allowed to get pretty lazy on sig figs, and for good reason. We had to focus on bigger fish. Okay. So I will say this to calm some anxiety. The philosophy of the ACS exams is similar to most teachers, where they don't play sig fig gotcha on most questions. The only place where they're really, disclaimer, who knows, maybe for this one I'm wrong on that. But like generally speaking, what I've seen over the years is most sig fig questions that actually care about sig figs, you'll see sig figs in the actual problem statement. They'll be like, how many sig figs in this measurement? Or to the correct number of sig figs, do this multiplication doohickey. Okay. So it's not like every question on there is secretly a sig fig question. I wouldn't have that mentality going in. Okay. So that being said, the first most important skill is sig figs in a measurement. Okay. So this is the battle of the zeros, right? You know, so if you had something written like this, we'll just say like milligrams, I don't know. You will get a question like that. I can guarantee it's always there. How many sig figs in some number like that? Okay. Okay. Left zeros get left off the sig fig count. Okay. Something like that. I don't know. That just popped into my head. Okay. Zeros on the left get left off the sig fig count. So then you'd be like, oh, 5. All right, so that was the first sig fig skill. The second sig fig skill is sig figs in addition and subtraction. And then the third one would be sig figs in multiplication and division. Okay. I'm gonna put stars wherever I think like you knew it at one point in time, you're probably decent at it, but you need to brush up. So I think temperatures gets a star for me. I think sig figs get a star for me. Okay. Your star list may look different than mine. Maybe you have this down pat in your sleeve. I don't know. Okay. All right. Questions? So I'll just keep on moving. Okay. Kind of intro to matter. Okay, and this ties into our lab experience as well. Change between solid, liquid, and gases. Okay, this is a physical change. Stuff like boiling, condensation. That's because there's no change in chemical formula. Okay. Anything else is a chemical change if you change the chemical formula. Okay. So just remember, going between solid, liquid, and gas, that's a physical change. Okay. All right. All right, and then so we did like classifying matter, in lab, there's like homogeneous versus heterogeneous mixture. And so homogeneous mixtures are also known as a solution, and you have mixing at the atomic or molecular level. And then for the hetero, you don't. You have separation. Hetero. Yeah, mixing at the atomic molecular level. Okay. Atomic / molecular level, level. I'm going to try to refrain from being word to word, seeing we have 24 minutes left. So, all right. And then we hit a big chapter, which was, oh no, before we get there, we have to get into ions. Okay. Something as simple as ions can trip people up. So for ions, you have to know, count your number of protons and number of electrons. Okay. And then we have isotopes. Okay. Okay. And we kind of got a quick refresher on that because of the nuclear chemistry we're doing right now. But just know what each of these symbols mean and how to calculate any of those. Okay, for the isotopes. Okay, and then isotopes then tied in to an atomic mass calculation. Okay, that's definitely going to get a green star. Okay, I suspect most people kind of forgot how to do that. My favorite example is carbon. So we did a carbon example in class. So if you're doing the atomic mass of carbon, you had 0.0101. That came from 1.01% carbon-13. And then you times it by its mass of 13.001 EMU. And then you added to it the 0.0989. That came from 98.9% carbon 12. And then its molar mass was 12.000 AMUs. And then you added them up, and then you got 12.01 AMU. Hopefully that's ringing a bell. You converted percentages into decimals, and then you multiplied by the masses given. Basically, the main things was convert percents to decimals, and then multiply that decimal for the mass for each isotope, and then just sum it all together. Okay. And if they're asking something from Earth, you check your answer with the periodic table. My suspicion is they will not ask something from Earth because, well, then the answer is there. That's too easy on a multiple choice. They're not grading for your work process. Okay, like I did on exam 1. Okay. So like if they're saying, hey, some hypothetical planet X has 40% this, 60% that, you would just use those numbers. Okay. And you can like check your work roughly. Like if they said you had 40% this, and then 50% that, okay, 60, then you would have a number that skews closer to 12 than 13. It's going to have to be some number in between, that's for sure. Okay. All right, and I think on the active practice final, I have like 1 or 2 examples of that sort of problem. Okay. All right. We got ions, we got isotopes. All right, I need a new page. Okay. All right. All right, here we go. We have electronic structure. Okay. Okay, so electronic structure. We have N, principal quantum number. Okay. N is equal to row number for S, and P. N is equal to row number -1 for D. N is equal to row number -2 for F. And when it comes to L equals 0 is S orbitals. So-called special PDF file, SPDF. And I don't know if you'll get any questions like ask you this knowledge like directly. I think it's more in an applied sense, okay? So in an applied sense, you're gonna apply it, and this will ring a bell. The things we had to do was the full electron configuration, the condensed electron configuration, and then we had either full or condensed orbital diagrams. They usually give full orbital diagrams instead of the condensed, unless it's like an exceptionally large element, like lead or something, but I haven't seen that too often. But basically what I'm getting at is know how to do electron configurations, know how to do orbital diagrams. Okay. And know how to do that for elements and for ions. Okay. Oh, I need to put one more thing in there. The most important one, good gravy. I mean, they're all important, but the number of valence electrons. Okay. I have a great video on my channel that we go through a bunch of different elements. I think we do sodium versus neon versus fluorine in my video. Okay. And we talk about their electron configurations as elements versus as ions. And we go through all of that. So I would strongly recommend that video. Okay. So I suspect plenty of people will need to brush up there. Okay. All right. I'll write a note for myself to check on if they have light or not. Okay, I will do a courtesy check on that. If they do have light, that'd be E equals H nu, C equals lambda nu, E equals HC over lambda. And some boring constants. 6.626 times 10 to the minus 34 joule seconds is Planck's, and speed of light is 3.00 times 10 to the 8th meters over seconds. In my experience, actually, y'all do a pretty decent job memorizing these. I think the thing people forget the most is if they have nanometers involved, and then you forget to do that conversion to meters if necessary. Okay. Yeah, I heard some size. Yeah, that's the one that trips up people the most. Yeah. Okay. Otherwise, just plug and chug. All right. Which one? Yeah, 10 to the 9 nanometers is 1 meter. In my experience, that's the one people forget more than these two. Okay. So I'll get back to you if they have light or not. All right. And then, oh, still writing. That's cool.
We have lecture on Monday, correct? Or no?
No. That's it. Unless like, actually, do I have time? No, Monday's no, we're on a Wednesday, Friday class. Okay, yeah.
Oh, yeah, I don't even know.
Yeah. Sweet. You almost had me believing that. All right, yeah, that's pretty good.
Forgot.
My colleague punks take advantage of my gullibility all the time. Anyways. Yeah, all right, and then other stuff here. So like, this doesn't feel like really intimidating. I feel like just visit the video where I go over the full condensed electron configured orbital diagrams for the ions and elements. If you got those, I think you got this down more or less. I think it's easy to overthink this stuff. And the other thing you got to know is the periodic table trends, right? They love those sorts of questions. Which atom is bigger? Which ion is bigger? Which metal is easy to take an electron off of? Stuff like that. All right. So we had atomic size, ionic size, okay, related topics. And then we had ionization energy, and then we had electronegativity. Okay, remember we were drawing like our fake, quick little periodic tables, and we're like, oh, size goes to the left and down for size. And we talked about how cesium's the biggest and helium's the littlest. Okay, so knowing those, okay, I guarantee you with these periodic trends, especially size, but any of them, you could have at least one question, but I'm guessing they're going to give you 2 to 3. They love those. I mean, I used to work for not the ACS Exams Institute. I used to work for the Chemistry Olympiad Exams Institute, which is part of ACS also. And I got a little bit of insight into how they like to write questions, and they love those. Okay. All right. And I think that about covers electronic structure. The natural progression of electronic structure is to then build molecules. Okay. With molecules, this probably gets a green star, right? This other one. All right. With molecules, you had to do number of valence electrons, right? And then you had to turn that into a Lewis structure, right? And then you had to do Vesper. All right, so we spent a lot of time in lecture and lab doing that stuff, okay? My recommendation, okay, there are 6 categories of geometry, okay? And so you don't confuse my dots. I'll put lone pairs like that. Okay. Oh, I should have done like that. Hollow circles. There we go. Okay. So we got 6 cases of geometries. With each of these, you should be able to punch out what the parent geometry is, also known as electronic. you should know what the molecular geometry is, and you should know the bond angle. And the parent geometry is tied with the bond angle. We really, really emphasize that in lecture and lab. Okay. Okay. But yeah, we were big on the process of get your number of valence electrons correct. That allows you to build a Lewis structure. That allows you to do Vesper. We talked about finishing octet on the outside atoms before you go inside. Okay. And we talked about if you run out of electrons, that is the only time you start considering double bonds or triple bonds. Okay. So I am guessing for most people, you completely forgot how to do that. And that's fine. It's been a long semester. Okay. My big pro tip is know an example molecule for each of the 6 cases. Okay. For me, these are my personal recommendations. A lot of these we did in lab. Okay. And there's more examples, but like if your brain has only room for 6, you know, maybe a better strategy is know 2 examples for each class. But even knowing these 6 will get you very far. Okay. Yeah, CH4, NH3, H2O. I mean, if you want like extra examples in case you wanted to ask, but you were afraid to do so. CHCl3, that's good. PF3. Oh, let's see. That's Cl2. It's a good one here. Oh, nitrate's a good one. NOCl is a good one for that one. HCN is a good one. Oh, you all need some ions, right? What if they give you polyatomics? That's another example. If you can do all these, I think you can do anything they throw at you. I can basically guarantee that. They're not going to do anything like really crappy like we did in lab where you had like 3 central atoms, or that's mean and stupid. Okay. They're only going to have like 1 central atom. All right. All right. Great. Keep this moving. I'm running out of paper. All right. Here's the one that some of you admitted to me. I was okay getting beat up on in the exam because I didn't really care about it. Well, it's going to come back to haunt you, and that's naming. Right? No one's laughing. Okay, I shouldn't be laughing. All right, so we had so like everything's a binary compound in the most part, just 2 elements unless you have like a polyatomic, right? So we had binary molecules. That means prefix, right? And then you had binary ionic compounds. Now it's like no prefix. Okay. And the argument is because of charges, you don't need prefixes. Okay. So like charges, man. Okay, you gotta use a periodic table. And you know, hopefully everyone can like do this in their sleep by now, but you go like 1, 2, 3, 4, 3, 2, 1, 0. I ran out of space. 1 plus 2 plus 3 plus 4 plus 3 minus 2 minus 1 minus 0, that whole thing. That's what you do for the binary ionic compounds. And that's how you get like subscripts, right? It is a little messy. Okay, that's how you get the subscript. Okay. And you gotta know how to go between a name and a formula in either direction. Okay. All right. And then we had a few other subcategories of ionic compounds. We had type 2, type 1 versus type 2 versus type 1 is no parentheses. And type 2 is yes parentheses. Because they're usually at transition metals. Okay, like iron 2+ versus 3+, all that sort of stuff. All right, they're really, they ain't gonna be esoteric, man. They're not gonna ask you about iridium. Okay, they're mostly like me, like, hey, if you see an iron or a cobalt, you know, you see something like a copper, can you recognize that if you're giving it a name, you got to slap some parentheses on it? That's all they're getting at. Okay. And then you got like polyatomic ions, all right? I got a nice piece of advice for polyatomic ions, okay? Familiarity, okay? Know the eights and the ites, okay? Perusing the exam, I feel like if you have a general sense of knowledge of eights versus ites, you'll be totally perfect, okay? I would not try to be like, well, Josh provided the ion sheet for us on the exam, we just filled it out. They could ask us any of 40 different polyatomic, they ain't like that, okay? They're gonna be like, hey, can you see that SO4 is a sulfate and not a sulfide? Can you see that NO2 should either have an ite or an ate sort of name and not be an ide? They're kind of just gonna be like that, okay? So in all honesty, polyatomic ions, I wouldn't spend more than 10, 20 minutes at it. I'm not even kidding, okay? So I'm gonna put a red star here saying don't sweat it. Okay. Okay. I don't want last semester, you know, I guess I didn't say this hard enough. I had someone like, I spent 3 hours learning polyatomic ion. I'm like, oh crap, I ruined your life. Okay. You know, I mean, do it makes your life happy, but I don't think you did that. All right. You know, I think just something like if you know that Na3N is sodium nitride, NaNO2 is a ite, NaNO3. If you just simply know why that's sodium nitrate, like I think you have plenty. Okay. And then the last part is of course acids. Okay. Yeah. You know, hydrochloric acid versus hypochlorous acid versus chlorous acid. You know, we had hydro with ick, we had just ick, and then we had us. Okay. And that depended on if you had ide, you know, this was ide, that was 8, and that was ite. Okay. So you can revisit that video if you want some stuff on that. My bride has hydraulics, Sprite is delicious. I ate something icky, all that stuff. Okay. Yeah, there might be an acid naming question, but I feel like the bulk of the naming, so like I definitely would study it, but the bulk of the naming is like binary molecules, binary ionic compounds, getting your charges right, and type 1 versus type 2. That's really where they're at. They're not going to overly hit you with polyatomic ions. Okay. So hopefully that calms some anxiety already. All right. And then after naming, the semester kind of took off in a math direction, right? And so that's where we started to like, well, balancing equations isn't like math. That's a little bit math. That was like math and stoichiometry, right? And that should be hopefully my last slide. We're running up against time. Okay. I know we started a little late. If you have to go, just go. You can catch the rest of the video. But otherwise, if you're here, I'm assuming you still want to see the rest of this. Okay. So the rest of the semester, we had reactions. Okay, this is where chemistry class actually started to feel a little bit like chemistry class. Okay. And so we had combination, decomposition, single displacement, double displacement, and combustion. And then our other categories, we had redox, we had precipitation, we had acid base, whoops. I don't think I've ever done that before. Acid base, and then we had gas formation. Okay. The reactions that eat beans. All right, so we have combination, decomp, single displacement, combust, all our redox, and then double displacement. Be either of those two. Okay. Few cases it's actually both, and any of these can be gas formation, so I didn't point anything at it. Okay. How much you have to like memorize this diagram? I don't know if you have to do terribly. Honestly, like if you don't really care about this diagram, but you just know how to do each of those reactions, you know, I had a lecture topic dedicated to each. I also have a video on my channel dedicated to each. Then I think you'd be golden. Okay. If you're still like struggling to balance equations, okay, the first thing I would learn is let me see, if still lost, I would first just do some warm-up pitches. Okay. Sorry, baseball analogy. Just learn to balance when they give you all the products. Okay. Then next I would try, they give you no products. So that would be the next thing I try. First try when they give you the products and just balance. Next, I would try no products. And then first you would predict the products. And then you balance afterwards. I think the easiest equations to balance, honestly, in my opinion, is combustion. That's where I would start. That's an easy win, and they often have combustion reactions in there. Okay. Then I would do, so I'd do that first. I do maybe this second or third. I do maybe single displacement fourth and double displacement last. I think we taught that in reverse order. I like to start with the hardest thing, I guess. I don't know. You don't have to agree with this order, just learn them all. Okay. So that was reactions. And then we had stoichiometry. Okay. So in stoichiometry, you had to go between grams and moles. And you also had to know how to go between grams to moles to moles to grams. Okay. Know how to do that, but in a limited time space, my guess is they're not going to have you do like all three at the same time. They'll ask you maybe to do one or two, you know, one or two, or just one. Okay. But because I don't know what they're going to ask you, know how to do all of it. Okay. And then the next thing was limiting reactant. All right. This is pretty recent, but if you're not good at it, brush up on it. I'm not going to put a green star on it because I think it's pretty darn recent. But yeah, limiting reactant, I gave two approaches. I gave the lowest yield method, and then I gave the have versus need table. Okay. All right. stoichiometry, limiting reactants, kind of like random mole conversions plus reactions equals stoichiometry. It's kind of like that. Okay. And then we finished the semester with some acid base. This is all fresh in our mind, and some nuclear. We didn't test on acid base or nuclear. This is where our testing ended. Actually, acid base was on the test, but nuclear chem wasn't on the test, but they like their nuclear questions. Okay, there's gonna be at least 1 or 2 nuclear reactions, and I know they almost always have a half-life. Okay. And that was our semester. Okay. So going through the packet this morning, I saw there's maybe 3 or 4 questions. I thought it would be like 10. Actually, we covered way more than I realized. So I give ourselves credit. There's like 3 or 4 topics we never covered. I ain't gonna grade those. Okay. Like a cell bio question, like what the bleep is that doing here? Always some man. You ain't gonna get that. All right. Thanks for a good semester, and see you all next time.
Thank you.
I'll leave chat open for a little bit. Everyone's, yeah.